Hello everyone, let's talk about another medium problem on Leetcode today. Minimum difference between largest and smallest values in 3 moves. Leetcode 1509. In this problem, we are given an integer array nums. In one move, we can choose one element of nums and change it to any value. Then we have to return the minimum difference between the largest and the smallest value of nums after performing at most 3 moves. So then they have given some examples as well. In example 1, we can see that array given is 5, 3, 2, 4, right? So in the first move, we change 2 to 3. So the array becomes 5, 3, 3, 4. In the second move, we change 4 to 3. The array becomes 5, 3, 3, 3. And then eventually, we change 5 to 3. So that will make all the elements equal to 3. So the difference between the maximum and minimum will be 0 in this case because it is 3 minus 3. Then we see example 2. We have 3 moves initially. In the first move, we change 5 to 0. So now our array becomes 1, 0, 0, 10, 14. So difference is right now 13. In the second move, we change 10 to 0. So now the elements become 1, 0, 0, 14. And the difference between the smallest and largest is still 13. And in the third move or the last move, we can change 14 to 1. So now elements become either 1 or 0, right? So the difference between the maximum and minimum in this case will be 1 minus 0 and it will be equal to 1. Now let's see how we can actually solve this problem. Suppose we have an input array with 8 elements 7, 4, 2, 9, 20, 13, 15 and 10. So what is the minimum in this case? It is 2, right? And maximum is 20. So the difference between them is 18. But now we have to make 3 moves in it, right? So that means we can actually cancel these two numbers out. So we can say, okay, 2 is equal to 20. So the difference between them becomes 0. We can either make 2 equal to 20 or 20 equal to 2. So suppose we made 20 equal to 2. So now minimum is still 2, but we have to still find the next maximum. So it will be 15. So now the difference between the minimum and maximum becomes 13 because minimum is 2 and maximum is 15, which is actually less than 18 that we had earlier. So I think setting the values is not that hard, but I think we have to keep on finding the minimum or maximum depending on what we are setting. So how about we actually sort this array so that there is some ordering and we can find the minimum and maximum elements in the array easily. Then our array becomes 2, 4, 7, 9, 10, 13, 15 and 20. So now for each move, we can easily cancel out the minimum and maximum elements in the array or chop out the extremes so that the difference between the minimum and maximum element keep on decreasing on each move. And after the 3 moves, we will return our answer. So it actually boils down to then 4 cases. So case 1 can be that we actually ignore or remove the last 3 or the largest 3 elements in the array. So what we can do is like 20 was our maximum, but we can actually take the 3 largest values, right, and ignore them completely. So then it becomes 10, 10, 10. So that means our maximum value is now 10 and minimum in this case is 2. So we will just get the difference equal to 8 between the minimum and maximum. Otherwise, what we can also do is in case 2, we can actually remove or ignore last 2 values. Those are the largest values and one of the minimum values. So now our minimum value becomes 4 and maximum becomes 13. The difference between them is 13 minus 4, which is 9. Similarly, for case 3, we will actually ignore one largest value and 2 smallest value so that it is equal to 3 moves again. Then difference between the minimum and maximum values, that is 7 and 15, is actually 8. Then in case 4, we can actually ignore all the 3 smallest values. So we will actually make them all equal to 9. And the difference between 20 and 9 will be 11. And now what will be our answer? The answer will be the minimum of all these 4 cases. So it will be minimum of 8, 9, 8 or 11. So it will be 8 in this case. Now notice that in case 1, in terms of array indices, the number maximum is actually nums of n minus 4, right? And minimum is num0 because we are ignoring the 3 largest values here. Similarly, in case 2, it is actually nums n minus 3, that is this value, right, minus nums1. Similarly, for case 3, it is num n minus 2 minus nums2. And for last case, actually, it is equal to nums n minus 1 minus nums3, right? Because we are choosing this element and this element. Now that we have seen this, let's jump into the code part. So first thing we will do is we will actually sort this array. But before that, we can check what is the size of the array. And if it is actually less than equal to 4, that means we can actually return 0. And the reason for this is like after the three moves, we would have ignored three numbers in it and there will be only one number remaining in it. So the difference between the same number will be 0. And now we will just sort this array and then just go through the cases one by one. If you remember, our case 1 was nums n minus 4 minus nums 0. Similarly, our case 2 was nums n minus 3 minus nums 1. Similarly, our case 3 was nums n minus 2 minus nums 2. Finally, our case 4 was nums n minus 1 minus nums 3. And now we will just return the minimum of all these four cases. If we just return math.minimum of case 1, case 2, and math.minimum of case 3 and case 4, and overall math.minimum of both. And that should be our answer. Now let's run this code. Awesome. Let's submit this code. Cool. In terms of time complexity, it is O of n log n, where n is the length of the array. And the reason is we are actually sorting this array. And in the average case, the time complexity for quick sort is n log n. And then getting these four cases is just O of one time because we are just getting it based on the array index. And in terms of space complexity, it is also O of one because we are not using any extra space or anything. Also, we can rewrite these cases as a loop because there is a pattern there. So what we can also do is for int I equal to 0, I less than equal to 3, I plus plus. And I think in this case, I should also define the minimum value. So let's say it's the difference between the last and the first value in the array. Now we will try to get the minimum value for each case. So if you see the pattern, it is n minus 1 plus 3 minus I. Sorry, minus 3 minus I, because if you see it's n minus 1 minus 3 and minus 1 minus 2. So value actually decreases with the I. So that's why we need the 3 minus I. And then we have to also get nums I from it. That's it. And in the end, we will just return the answer. Let's now run this code. Awesome. Let's submit the code. Cool. Again, the time complexity stays the same. And the question is, can we do better? And the answer is yes. Asymptotically, we can still do better because if you look at this array closely, what we need is four largest values in the array and then four smallest value in the array, right? And then we actually just pick up one of these values in the cases and then try to find the difference between the maximum and minimum based on it. To find out four maximum values in the array can take O of n time. Similarly, to find out the four minimum values will also take O of n time. And then we can just go through the four cases that takes us O of 4 or O of 1 time. So if you are interested in that code, please check it out on my blog. I have shared the blog link in the video description. I still prefer this sorting approach because the code is simpler and easy to understand. But up to you. And I hope this video was useful to you. If it was, please like and subscribe. Have a nice time.